Welcome to our DELMIA podcast, Global Operations on the Go. I'm your host, Therese Snow. Today, I have the pleasure of speaking with Buddhi Ratawal, DELMIA Business Development and Marketing Manager. Buddhi, welcome.
Thank you, and very happy to be here, Zadis.
Excellent. Happy to have you. So, Buddhi, let's start by telling our listeners a little about yourself.
Sure. I'm a strategic business development and marketing manager with the DELMIA brand of Dassault Systems. And it is my job and my pleasure to be the evangelist for DELMIA Robotics, which is a robotics programming and simulation solution centered around promoting sustainability in manufacturing.
Fabulous. This sounds really interesting. Perfect fit for the show today. So glad you're here. So you are here to discuss sustainability in automotive manufacturing and how Robotics Virtual Twin plays a role. Can you tell us why exactly is sustainability important in automotive manufacturing?
Sure. See, cars are probably one of the most widely sold and pervasive engineering creations in human history. I came across a very interesting statistic the other day that an average American goes through 8 to 10 cars in their lifetime. And it's because it is such a marvelous piece of engineering, and also because of the utility that cars are traded at such a massive scale all around the world. Now, of course, it comes at a cost. Manufacturing a car involves several processes, each contributing to GHG emissions. If we were to break down the process in three big steps, it include first extracting raw materials, second is manufacturing and assembling components, and third is transporting vehicles. Now, mining and processing metals like steel and aluminum and extracting petroleum for plastics all emits greenhouse gases. During the manufacturing phase, energy intensive processes like welding, painting, and assembly line operations, they also release carbon dioxide and other gases. And finally, moving parts and vehicles between suppliers, assembly plants, and markets adds to this emission. Now, let us just focus on the manufacturing part, since that is going to be the focus of our conversation today. On average, manufacturing a single car can produce around 10,000 kilogram of carbon dioxide equivalents. Now, to put this into perspective, 10,000 kg CO2 is equivalent to driving approximately 25,000 miles or 40,000 kilometers in an average gasoline car. Or it is equivalent to the energy consumption of an average American household in a year. And when you multiply this with 85.2 million, which is the number of cars produced in the year 2022, you arrive at the massive scale of emission from automotive industry, and that too just from the manufacturing phase. I'm not even talking about the users phase yet. And just to put this into further perspective, the emission from the manufacturing of cars that contributes to 8% of the total anthropogenic emissions. It means the emissions from human activities such as manufacturing, farming, transportation, etc., as opposed to natural emission such as volcanic eruptions and natural decay of organic matter. We can't do much about them. Now, coming back to the point, the scale of greenhouse gas emission from these manufacturing of cars is so large that sustainability automatically becomes a concern and a hot topic in the context.
No, absolutely. Those numbers are very significant. I could see where this could completely be a hot topic. So that's really interesting. Can you tell me, does Delmia Virtual Twin, in fact, help automotive manufacturers stay or become sustainable, especially giving these significant numbers as you mentioned? And if so, how?
Yes, sustainability is a journey, so you continuously improve, and Delmia Robotics is a tool to help you with that. See, before we talk about Delmia Robotics, which is essentially a virtual twin experience-based programming and simulation solution, let's talk about the robotic automation first. Fundamentally, robotic automation prioritizes operational efficiency and productivity. It streamlines processes and reduces human error, but it often overlooks environmental concerns like resource consumption or waste generation or carbon emissions. In fact, the robotic automation has unintended negative consequences on the environment. So while it eliminates some manual tasks, robotic automation may lead to increased production. Of course, that is the intent, and it can drive higher energy and resource demands. Also, robotic automation relies on energy-intensive machinery powered by non-renewable resources, and all of this contributes to greenhouse gas emissions and environmental issues. In this context, the concept of robotics virtual twin is a game changer. By combining virtual simulation with real-time data from physical robots, robotic virtual twin enables analysis and optimization and makes possible informed decision making. RVT also, by RVT, I mean the robotic virtual twin. It also enables comprehensive virtual testing, analysis, and optimization of robotic systems before their actual deployment in the physical world. So by creating a virtual twin of the robot, engineers, manufacturers, all of them can simulate various scenarios. They can evaluate performance, identify any potential issues, and make any necessary improvements without the need for physical prototypes.
All right, so Buddhi, so when you talk about this and you talk about robotics virtual twin and automotive, are you referring to what? To robotics helping with assembly, material handling, painting, or what exactly?
Yeah, all of them actually. Have you? In fact,
Okay.
automotive automotive is by far the most automated industry. Just to give you a sense of how much the automotive industry is ahead of other industries, in South Korea, the average number of robots per 10,000 workers in non-auto industries is 450.
Hmm.
And you know how much is the same number for auto industry?
What is
Not
it?
double. It's
Mhm.
it's 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 not double, not triple, not even quadruple, but almost 5 times as many robots.
Wow.
So there are close to 2,200 robots per 10,000 workers in auto industry in South Korea. And that trend is consistent across all major manufacturing economies around the globe. So robotics finds application in many different processes in car manufacturing. In welding, where robots are used to join metal sheets together at specific points using high current pulses, the process is called spot welding. Similarly, we have arc welding, where robots can be used to join metal components with precision. uh, Robots also assist in assembling various components of the vehicle with precision and speed. They handle materials efficiently, reducing manual handling and associated waste. Uh, in certain surface processes, such as painting or sealant deposition, robotics ensure uniform and efficient application. Also, with the advancement in AI and computer vision, robots are used in quality inspection as well.
Well, it sounds like robots are used pretty much in any aspect here. So, can you tell me what exactly are the benefits, for example, of an auto plant using robotics virtual twin as far as sustainability is concerned?
Yeah. So robotics virtual twin technology involves creating a precise digital replica of a physical robotic system and its operational environment as well. So this digital twin or virtual twin allows for extensive simulation, testing, and optimization before any physical deployment. And this is particularly valuable in automotive manufacturing, where efficiency and precision are crucial. Now, this virtual twin helps reduce waste. By using this virtual twin, manufacturers can simulate and test different design iterations and production processes virtually. This helps identify and eliminate potential inefficiencies or design flaws that could lead to material waste. For example, virtual simulations can help optimize the amount of material needed, reducing excess scrap and rework. Virtual twin also allows for comprehensive testing and validation of processes and designs, which can detect errors or defects before they occur in the physical production line. This significantly reduces the need for additional materials to correct mistakes. Apart from reducing waste, RVT can help in reducing energy consumption also. Through virtual simulations, manufacturers can test various robot configurations and motions to find the most energy efficient setups. This helps balance energy and efficiency, leading to lower energy consumptions, during production. Virtual twin also helps streamline workflows by optimizing the sequence of operations and movement of robots. This reduces unnecessary energy use and it enhances the overall production efficiency.
So does robotics virtual twin actually affect the speed or quality of a manufactured part?
Yes,
Mhm.
the robotics virtual twin technology can significantly impact both the speed as well as the quality of the manufactured parts. The virtual twin has threefold impact on the speed of manufacturing. So one, that virtual twins they enable rapid adjustments to process without the need to halt physical production lines. So you are doing everything virtually and you don't need to halt the physical production lines, and then changes can be tested and refined virtually. So there is minimal disruption to manufacturing speed, so it reduces the downtime because you are doing everything virtually, so you don't need to do it in real world, and therefore the need to put everything down is reduced. Second is that the new production lines or changes to existing lines can be virtually commissioned and debugged before the actual implementation. So it can significantly reduce the time required to ramp up production. And then finally, by analyzing and optimizing the movement and operations of robots, the virtual twin can eliminate unnecessary steps, and then it can streamline workflows, and that leads to a faster production time. And then similarly, the virtual twin also improves the quality of manufacturing. Virtual twin ensures that robots are precisely calibrated and their movements are optimized, and it leads to higher accuracy and sort of consistency in the manufacturing of parts. Second is that defect detection at early stage. Uh, Advanced analytics and machine learning integrated into the virtual twin can detect anomalies and potential defects early in the process, preventing any faulting parts from proceeding, down the production line. And then finally, the virtual twin allows for thorough testing and validation of part designs in a virtual environment before physical production begins.
Mhm.
So virtual twins can simulate how parts will perform under various conditions, identifying any potential weaknesses and allowing for any design adjustments.
Definitely sounds like a lot of benefits. That's clear and really interesting as well. So, Buddhi, can you tell me, is there anything else that you would like to add that perhaps I have not asked?
Yes, one topic that we did not talk about is regulatory compliance. So the
Mhm.
virtual twin makes it tremendously easy for manufacturers to comply with environmental regulation. Virtual simulations can predict the environmental effect of manufacturing processes, and this allows the manufacturers to test and refine their processes to ensure that they meet regulatory standards before implementing them on the production floor. And additionally, the integrated sensors and IoT devices in robotics collect real-time data on energy consumption and emissions and waste. And this data is fed into the virtual twin, which continuously monitors and assesses the sustainability performance of the manufacturing processes. And if a process deviates from compliance thresholds, the system can instantly alert operators and suggest corrective actions, thereby ensuring that immediate response to potential regulatory issues is given.
Absolutely. Well, it has been a pleasure speaking with you, Buddhi, and hearing how robotics virtual twin can make automotive manufacturers more sustainable. Appreciate it. And thanks again for being a guest on the show.
Thanks for having me, Therese. It was a pleasure discussing how robotics can enhance, sustainability in automotive manufacturing.
Oh, absolutely. And thanks to our listeners for tuning in. To learn more about DELMIA Robotics Virtual Twin and sustainability, click on the link where this podcast is posted. I'm your host, Therese Snow, and you've been listening to Dummies Podcast, Global Operations on the Go.